And what is the other possibility? There is a cross conjugation. This is undergoing cross conjugation. Means the -1 charge is shared among these 4 carbon and 1 oxygen. If lone pair undergoing, in this RS we can change position of pi bond. 2 RS will be there. If the resonance takes place, in case of no resonance, we will simply write resonance is not possible. And one of the structure is already asked in JEE Advanced. There are 3 possibilities to start drawing resonating structure. You can start with any one of them. So while drawing different type of resonating structure, one of the common mistake is there. Again, we can solve this question by 3 different ways. You can start by 3 different ways. Pi bond in between these 2 carbon. Positive is delocalized. Positive is localized, but there is a resonance between negative charge and pi bond. In previous case too, the movement of 2 electron was there. 2 electron are moving. Hello to everyone. Now, first of all, we will start today's lecture by the homework which I had given in our last lecture. Hopefully, you have tried. So, let's discuss the answer of the questions which I have given you as a homework. Now, in this example, there will be a total number of RS will be 6. How 6? If the lone pair undergo resonance, start with lone pair. This means negative charge will be at ortho position. Then again, if we undergo resonance of this lone pair, then negative charge will be at para position. Now, once we draw negative charge at para, then there are 2 possibilities. This negative charge can delocalize with C double bond O. Double bond conjugation with lone pair means negative charge will be moved toward oxygen. And what is the other possibility? There is a cross conjugation. This is undergoing cross conjugation. So, this means this lone pair can move on upper ortho position. So, next possibility is if I move lone pair on upper side, this is negative. How many RS will form? This is 1, 2, 3, 4, 5 and 6. And where will be the negative charge? Negative charge will be on carbon, then ortho carbon, this carbon and oxygen. So, this will be the resonance hybrid. Means the -1 charge is shared among these 4 carbon and 1 oxygen. Similarly, in 16 example, when you draw resonance, the negative charge will be on ortho, then this ortho and then down oxygen. Exactly similar to 15. Then this will be the hybrid. You can match your answer with the given hybrid. In example 17, there will be a 5 RS and 18 will be 5. How 17, 5? This lone pair delocalize on this carbon, then this carbon, then this carbon and this carbon. 4 carbon and change in position of pi bond of the ring. The 5th structure is change in position of pi bond of the ring. In that way, there will be a 5 RS and negative charge will be shared among 4 carbon. Now, in 18, lone pair convert into pi bond, negative charge will be at ortho position, para position and ortho position. Got it? And what is the charge on oxygen? There will be a positive charge on oxygen and there will be a negative charge on carbon. Because the lone pair of oxygen undergoing delocalization, this means O will consist of positive charge. Total 5 RS will be there. Now, in 19. Now, in 19, the lone pair can undergo resonance on right hand side. So, we can draw this as a resonating structure, or lone pair can undergo resonance on left hand side. Then this will be the resonating structure. In both RS, oxygen has positive charge. Now this lone pair will further undergo delocalization. In that way, there will be a total 6 RS. How 6 RS? If lone pair undergoing, in this RS, we can change position of pi bond. 2 RS will be there. And if lone pair undergo resonance on right hand side, again we can change position of pi bond, 4 RS. And then ortho, para and ortho. This means the total RS will be 7 RS. Got it? You have to write 7 RS. Now in 20th example, there is a cross conjugation. Means lone pair can undergo resonance right hand side, left hand side. This means these two carbon will carry negative charge and oxygen will carry positive charge. So total RS will be 3 RS. How 3 RS? The given is also RS. This is also RS. Lone pair on right hand side, lone pair on left hand side. Got it? Remove this pi bond. Now match this answer. In 21st, what is the type of resonance? This lone pair delocalized with pi bond. So lone pair convert into pi bond convert into lone pair. This means there will be a 2 RS. And what is the resonance hybrid? In resonance hybrid, nitrogen consists of delta plus and oxygen consists of delta minus. Now in 22nd, this lone pair and pi bond are not in conjugation. There is no resonance. Therefore, we will not mention any number. Since the number indicate if the resonance takes place. In case of no resonance, we will simply write resonance is not possible. Why? Because of absence of conjugation. We cannot move lone pair here because carbon become pentavalent. In 23rd, we will start lone pair to pi bond, then pi bond will, lone pair will further undergo resonance. So how many RS? This 1, 2 and 3. Now in 24, 25, 24th again ester, double bond conjugation with lone pair. Lone pair convert into pi bond to lone pair. So this will be the structure. O consists of positive and negative. So how many RS will form? 2 RS. In 25th, this lone pair convert into pi bond to lone pair. This means chlorine consists of plus and oxygen consists of minus. 26th and 27th are important, and one of them is already, one of the structure is already asked in JEE Advanced. So there is a total number of RS are 10. Pause the video and try to draw 10 resonating structures. If your answer is 6, 7 or 8 or 9, then try to find remaining resonating structures. Where are the remaining structures? Now this is the answer. Now what you can do, first of all, one of the approach of this type of question is, this is a naphthalene. So we can start the first resonating structure by 3 different ways. In first way, I can place pi bond here. In second, I can start when pi bond is in between 2 rings, or I can start when pi bond is on left hand side. Means pi bond on this carbon, or in this carbon, or this carbon. This means there are 3 possibilities to start drawing resonating structure. You can start with any one of them. So let us start with this first, then lone pair to pi bond to lone pair. Got it? Now once the negative charge come here, there will be a cross conjugation. The resonance, if I do resonance with upper pi bond, negative charge will be on this carbon. If lone pair on lower pi bond, negative charge on this carbon. Got it? So in that way, this is negative and this is negative. Got it? If I undergo conjugation with this pi bond, I will get this. If I undergo conjugation of this pi bond, if I draw conjugation of this pi bond, I will got this. So while drawing different type of resonating structure, one of the common mistake is there. The student simply draw in a sequence A to B, B to C, D, E, F. But you have to check. There may be a multiple, there will be a cross conjugation, either A to B, then going B to C, there may be a B to G. Got it? Just like a product and side product. Similarly, you should check cross conjugation in between different RS. Now let's move ahead. Then move this pi bond. I will got this RS. Then again, if I move this pi bond, I will got negative here. If I again move pi bond, I will got negative here. Again move pi bond, I will got negative here. Got it? So how many RS are there? And the first one and this one, that is 1, 2, 3, 4, 5, 6, 7, and this is our 8, and this is our 9th. And which is the 10th? This and this is identical. These two are identical. And if I start with this, if lone pair conjugation with pi bond, if this lone pair undergo resonance, this will be the RS. Now this RS is different from this one. This is different from C double bond O, consists of C double bond O and consists of benzene ring. This means this and this are different because the pi bond in between two ring and the pi bond it is on left hand side. This means the 10th one will be from the second RS. Similarly, if I draw this RS, lone pair to pi bond to lone pair, then what happen? Then this will come. This means it is a repeating. So in order to delocalize this negative charge, I will get repeating structures. That's why I am not drawing this, but this is different. In that way, 8, 9 and this will be our 10th RS. Got it? Now, if the negative charge at beta position of naphthalene, then will be a 9 RS. Again, we can solve this question by 3 different ways. You can start by 3 different ways: pi bond in between these 2 carbon, in between these 2 carbon, or in between these 2 carbon. So let us start the pi bond from left hand side. The lone pair convert into pi bond convert into lone pair. I will get this. Then lone pair to pi bond to lone pair. I will get this. Lone pair to pi bond to lone pair. I will get this. Then again this lone pair to pi bond to lone pair. I will get this. Then lone pair to pi bond to lone pair. I will get this. Lone pair to pi bond to lone pair. I will get this. Got it? How many RS will be there? And similarly, this negative can undergo cross conjugation. It can undergo upper pi bond, and if I do resonance with this pi bond, this can undergo resonance with this pi bond as well as this pi bond. If I undergo resonance with this pi bond, negative charge on come on this carbon. Again, conjugation on this carbon. What about this first and this one? They are different because of change in position of pi bond. Similarly, this and this are different because of change in position of pi bond. Ultimately, whatever the option you will start, if you start with the pi bond in between two ring, you will get the same number of RS. If you start pi bond between the left and right hand side ring, you will get the same RS. So you can start with any one of the RS. 1, 2, 3, 4, 5, 6, 7, 8 and 9. So there will be a 9 RS. This is our IIT JEE advanced question. Got it? Now let's start with 27th example. The lone pair convert into pi bond to lone pair. This means negative charge will be on this carbon, then this carbon, then this carbon, this carbon. Then this is the resonance hybrid. Negative charge oxygen, then carbon, 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 carbon. Now in 28th, we will start with lone pair to pi bond to lone pair. What is the resonating structure? Nitrogen consists of positive, carbon consists of negative. Then again delocalize. This means this carbon and this carbon consist of negative charge and nitrogen consists of positive charge. This will be the resonance hybrid. And in 29th, lone pair undergo resonance, negative come on this carbon, and then this carbon. And one more thing is there, the NO2 will also undergo resonance. If there is a NO2, this means negative and pi bond undergo delocalization. We can draw this RS. Got it? Positive is delocalized, positive is localized, but there is a resonance between negative charge and pi bond. Double bond conjugation will lone pair. So this will be the RS. In that way, oxygen, both oxygen will carry negative charge. And nitrogen positive is localized, therefore in hybrid nitrogen will have complete positive charge. Got it? Now in 30, there are two RS. This lone pair is localized or delocalized? This is our localized, means it will not undergo resonance. Means if I am discuss any property of this lone pair, for example, I am discussing basic strength, acidic strength, at that time I will say this will not undergo delocalized. Means whenever we are discussing the property of nitrogen, lone pair of nitrogen are localized. Got it? Now in this case, if anyone asks how many RS of benzylamine, there will be a 2 RS. The first RS is this and second will be delocalization of pi bond. In this case, if negative is placed on this carbon, we can change pi bond of ring. Similarly, if negative is delocalized, then again we can change pi bond of ring. And this carbon is sp3. sp3 means it will not undergo resonance. So there will be a 2 RS. And what is the resonance hybrid? Only these 3 carbon will carry negative, 2 carbon will carry negative charge and these 3 carbon will undergo resonance with negative charge. So there will be a delta minus, delta minus. Got it? Now let's start with our case 3. Now in case 1, what is the case 1? Double bond conjugation with positive charge or vacant p orbital. Case 2, double bond conjugation with lone pair or pi electron. In case 3, double bond conjugation with phi radical. This is our dot means phi radical. Now in previous case 2, the movement of 2 electron was there. 2 electron are moving. Now in this phi radical, only 1 electron is moving. Just like a person, there are 2 type of person are there. One is married and one is unmarried. The unmarried person used to move alone, and after marriage, he or she have to move in pair. So now it is unmarried. Phi radical is just like a unmarried. Now what you have to do? The double bond conjugation with phi radical. This is our case. When double bond in conjugation with phi radical. Now for phi radical, we have to use single headed arrow. There will be a homolytic cleavage and 1 electron and 1 electron pi bond will form pi bond and this electron will move here. Yani if I number this carbon, now the pi bond is in between 2, 3 and in resonating structure the pi bond will be in between 1, 2. Got it? Now this electron is delocalized. Now how to draw hybrid? If there is a positive charge, we will write delta plus, delta plus. If there is a negative charge, we will write delta minus, delta minus. Similarly, in case of radical, we will write delta dot and delta dot. In positive, delta plus, in negative, delta minus, and in radical, delta dot. Now try this example. You have to draw resonating structures and you have to draw resonance hybrid. Now this free radical undergo resonance. So there will be a 2rs. And what is the resonance hybrid? Delta dot, delta dot. Now in this case, there will be no resonance because of absence of conjugation. Because pi bond and free radical, in between pi bond and free radical, there is a sp3 hybridized carbon, or we can say that separated by 2 sigma bond. And in conjugation, it must be separated by 1 sigma bond. Now in this case, there will be a 3rs. Radical move from 1 to 3, then 3 to 5. And what is the resonance hybrid? Delta dot, delta dot, delta dot. Got it? Now in 5th example, draw all the RS and draw hybrid. Now 5th, there will be a 2rs. This free radical undergo here, then here. And what is the second RS? This is the second RS. And what is the resonance hybrid? Delta dot, delta dot. In 6th, there will be a 5 RS. First free radical will move toward ortho position. Then further, then para, then ortho. Radical will be on this carbon, this carbon, this carbon, this carbon. Now in example 7th, the radical will be on this carbon, and after undergoing resonance, this carbon will carry radical. Then it move to second ring in ortho position, this para position, ortho position. Means the radical is moving shared by or moving toward 5 carbons. Got it? You simply write delta dot across all the 5 carbon. Now try these 2 examples. Now in 8th, this free radical will undergo resonance with this pi bond. This phenyl ring will not undergo resonance with radical, because in order to undergo resonance with phenyl ring, the radical must be on alpha carbon, or we can say radical must be on this carbon. Now this is bypassing, this means simply radical is delocalized among 2 carbon. In 9th, there will be a 5 RS. I already explained you example of carbanion. The radical will be on first carbon, then it will move toward 3rd carbon, then it will move toward 5th carbon. After 5th, it will move toward 2nd carbon, then move toward 4th carbon. The initially radical directly move to 3, away from the his neighbor atom. He is away from the neighbor, go to 3, then go to 5, then again come back to neighbor 2, and then go to 4. In that way, there will be a 5 RS, means the radical is shared among, free radical is delocalized among 5 carbon. Not shared is not a proper word, it is better to delocalized. Now that's all for today. Hopefully you have learned a lot from this lecture. Keep learning, keep trying. They are 2 important things. Keep learning and keep trying, and you will improve day by day. If you like the video, then please subscribe and please like. And where are you from watching this lecture? Please write in comment section. You are watching from Tamil Nadu, Kerala, Karnataka, Orissa, whatever in the state or country you are watching. So just write in comment box where are you from watching, and try to follow all the lecture. Don't skip lecture in between. If you follow all the lecture and write properly, then definitely your organic chemistry will improve and you will score good in organic chemistry in JEE and NEET and other competitive exams. Thank you. Have a nice day.